Hey, Dr. Wilson, this is the Future CPAs group. We're doing our Accounting 309 Data Regression project. This is part one. Before we get started, we're just going to introduce ourselves. I'm Jarrett Lee.
I'm Charlotte Thomas.
Just David State.
Haley Mescalin. John Patel.
All right, now that we know everyone, let's get started on the project. So we are going to be pulling data from Accounting 200. We are using the data to predict total points earned for students. So I'm going to share my screen. Get there real quick. All right, this one right here. I gotta do this. Okay, here we go. All right, this is the right data. Okay, so who wants to go over the first step?
I'll take over. Okay. So we are first going to replace all the empty cells with zeros because we're assuming that a student that didn't take the test, we're going to give them a 0. So first we're going find and select, and then replace, and then we're going to find the dashes, and we're going to replace it with zeros, and then we're just going to replace all, and it made 353 replacements, and then we're going to close out on that, and then we are going to do our correlation. All right.
So you want me to do correlation analysis, or?
I mean, I can do it. So we're not doing maximum points, right?
Yeah, so we have to move maximum possible score on the other side of total points earned so we can do a correlation analysis, because we're not using maximum possible score points, because that's just saying what you can earn, but that's not what was made or earned in the class.
We're having technical difficulties. Okay, so data.
Okay, there you go.
All right, data, and then we go to data analysis, and then we're going to do a correlation. You hit OK. So our input range is going to be all this. All right, and then we had our labels. We're going to hit labels, hit OK, and then this is our correlation.
Yeah. So correlation analysis is we're trying to figure out which independent variables are highly correlated with our dependent variables so we can get a good model. And to figure out that, we're going to have a certain number we're looking for, which I think is 0.70 in this case. So the first thing we want to do is just see which variables are highly correlated. And so to do that, select our data here. Select. All right, and then we're going to go to conditional formatting. Highlight between. So we want to know any cell between 0.7 and 0.99, so we don't want to use 1. All right. So it gave us back feedback on which ones are highly correlated. So if you notice under the first column, there's all the independent variables that we could use, but we're not going to use all of them due to multicollinearity. And that's when 2 independent variables are highly correlated with each other. Just Adrius, do you want to kind of talk on that some more?
Yes, so you would not want to use 2 independent variables that are highly correlated, as this could interfere with how your data is aligned with each other. And so let's say if you have one assignment that highly correlates with, for instance, you'll see exam 1 and 3 highly correlate with each other. You won't want that, because there might be some underlying factor that could interfere with your results and cause you to get unreasonable amount of correlation. The correlation that's in there, it'll make your result be off. So you won't have a true prediction for the grades that you'll get in Accounting 200. for instance, you could have similar course instruction on both exams. And so that wouldn't, if it's similar course instruction on it, then you can't say that exam 3 will truly help you identify how well you will do in the class going forward, because it had some similar instructions earlier. So there's no new instruction there. So you wouldn't want that in your data analysis moving forward.
So now that we understand what multicollinearity is and that we don't want it, we now have to determine which variables to cut out. And so to do that, just get my chair over here. We're just going to start with our first variables and just work our way down. So on exam 1 right here, we go all the way across. Well, we see so far nothing across it is related. And then we can go and we can find the exam 1 that's up here. I believe that's exam 2. So here's our exam 1. We go down, we also see no independent variables highly correlated with. So we know we're keeping exam 1. So Jockey, do you want to talk about exam 2? Trying to figure out which variables are related. So we know we're keeping exam 1. So I'm going to make a keep and then a cut column. So we're keeping, and I just filled it out. Right.
Okay, so for exam 2, it's right here. Okay, well, it's exam 2 is right here. So we go across, nothing so far, and then you find it over here. Is that right?
Yeah.
And then, yeah, you see it's correlated with exam 3. So those are correlated with each other. We don't want to use that. We are going to cut that out.
Down here, I'll say cut out.
Okay, and then we do the same thing for exam 3. Go across, and it's correlated with exam 2.
Which we cut out. So
yeah.
Then we check the column.
Okay, the column for exam.
It's right here.
Reading this one.
Yeah.
How do you do that? All right. Okay.
Okay.
Yeah. So exam 3 is correlated with 2 things right here. Go across. It's chapter 10 exercises and the lecture for chapter 12 pre-lecture. So we want to cut that out too, also just because it is multicollinearity, and you won't be able to differentiate between the two because they're too correlated. So,
Exam 3. So moving forward, let's just check out. We can go into the rest. Chapter 10. You go across. It's related to exam 3, which we cut out. But if you find, I think chapter 10. Let's see if we can find it. Chapter 10 exercises. We see that it's related to pre-lecture chapter 11. I think. Oh, wait. Yeah, pre-lecture chapter 11. So again, we cut out chapter 10 exercise. All right. Chapter 11. Go across, it's related to exam 3 and chapter 10. We cut those out, but coming down, we see it's related to exam 4. So cut that out. Looking at exam 4, it's related to exam 3 and exam 11, but we cut those out. And if we come down, we see it's not related to anything. And since we cut those out, we can use exam 4. So now we have which variables we're going to use to run the data regression, and that is going to be exam 1 and exam 4. So,
and just to reiterate, the reason why we're using those 2 exams is just so you can see this on the point of view of the data tester and for the student, you can say that, hey, these are 2 independent variables that do not correlate with each other in the slightest. And so you can be fairly confident later on, once you start to predict your grade, that you'll have true confidence in your results.
Yeah. I think a good example was, I think one you gave Dr. Wilson with the salts and
the onions
and stuff. If you're trying to figure out what made the chicken the saltiest, and you use table salt, sea salt, and all that, it'd be hard to predict that because they're related to each other. So that's kind of what we're explaining here. So now we're going to do data regression, and we're only using exam 1, exam 4, and our total points earned. So we need to go back to this right here. And we just need to move everything beside each other because in order to run a data regression, they have to be beside each other in Excel. Copy here and go over on our total points earned, insert, and then exam 4, do the same thing. All right, so now we're going to run our data regression. And to do that, you want to kind of show how we do the data regression? Charlie's going to explain.
You go to data analysis. Oh my gosh, I do not know how to work a Windows computer.
Oh, you're the
You might
already
have to.
analyze data.
Okay. Okay, I was like, I can't handle this clicker. All right, so you go to data analysis, and you're gonna go down to regression. Regress, okay. And then you're gonna select for the Y range.
Y range is going to be a dependent variable. See a total points on it.
Yes.
That's what we're thinking.
And we're gonna select all of this.
Yeah, the one to the right. We're column E.
Just like all of them. All right. Yeah.
And then
click grab.
like click on total points on, like just
Grab it. Okay.
yeah. Sorry, we're not used to all these computers.
Yeah.
All right.
Okay, so on E.
Yeah. Click on E. Right there.
And then
All the
just
way down,
drag
all the way
it.
down, all the way down.
Yeah. Yeah, okay, there we go. Solid
So,
0. Okay, and then we're gonna go to the X. I'm gonna come up here and we're gonna do the 2 exams. All right, I'm just gonna drag it up.
do that, I'll show you.
Hold on. I'm not used to this mouse pad.
Do it, just click and then hold it
Yeah.
all the way up.
Yeah. And then
So,
okay.
you know, our confidence level is 95%. We want that,
Yeah.
and we want to put it in the worksheet. So,
And there it is.
and now we need to, let's see. So, do you want to talk about R squared real quick?
Yeah, so with the R square, it's 0.90. So it's saying that there's a 90% chance, the grades that we see is 90% of our grade in the class. Like the grades from those tests is 90% of the grade, your overall grade in the class.
Yeah.
90% prediction.
90%,
90%
yeah.
prediction.
It's saying that our independent variables explain 90% of what we get to be the dependent variable in our model.
So from the perspective, again, from if you would like to look at it from 2 different sides of the same coin. So from the data tester, you can pretty much say that, hey, I can be 90% sure that whatever grades you input, you're gonna get these grades. And so for the student, it creates a confidence level between the data tester and the student so that the student knows, hey, if I was to use this model, I can be 90% certain that whatever grades I input into this model is gonna give me a 90% certainty that this is what my grade is gonna be.
Yes. So I'm gonna highlight that just to yeah. All right, okay, and the next thing that we want to look at is the significance F. So we see it's scientific notation. So so we're gonna press the apostrophe button to not apostrophe. Yeah, and this number it needs to be less than 0.005. Okay. So we see that.
And since it's less than 0.05, this means that our model is going to be a good model because our F value is less than 0.05. And now we can check our p-values.
Yes.
They don't focus on the model as a whole, they focus on the variables that we use itself. So, so we see that the p-value for ACC 200, I think that's exam 1 is 0.00. It's less than
Yeah.
0.05.
We're gonna change it. And it's also 0, 0.
Yeah, it's also 0.00 for the other exam. So that means we have very good models here, very good variables here for our model. If you see the intercept is greater than 0.05, but that doesn't matter since it's the y-intercept. From here, now we will build a model. Jockey, do you want to build a model?
The equation?
Yeah.
Okay, yes.
Let me
Yeah, I'm gonna.
clarify. So you know which one's good.
Okay.
Which one?
So our equation is going to be y equals our coefficient for, can you,
All right, so y here is equal. There we go. Y equals.
our coefficient for the intercept, which is
Maybe the equal sign.
plus oh my god, why is it not? Oh, that's the inner. Okay. Plus the coefficient.
Yeah, I got you.
Why is it?
All right.
I'm not used to this type of laptop.
Yeah, sorry.
Plus the coefficient for the exam 1 times, yes, whatever grade
We'll
we're
come
gonna
back
put
to
in.
that.
Plus, oh, what did you do? The inner?
Yeah.
Okay. And then plus the coefficient for the second grade.
Mhm.
And that is our equation.
So, and I'll label this real quick. Total points earned. I'll come up here real quick. Is equal to y intercept down 4. So now that we have our model, our equation, we can now just throw some grades out there to see what a serious student would earn. So since we're talking serious, we assume they're going to do well and they want to know how they do. So what numbers?
So I would say for exam 1, let's we can be realistic and say that they don't know how to test the model yet, so they make an 87.
Okay. So we'll come down here. So we're going to come right here. So say the equal, just the intercept. Plus, you said 87. Let's say this is our coefficient here. And we're going to multiply the variable, the coefficient for exam 1. We're going to multiply that by 87. And then what do you want to do for exam 4?
We did better.
We did better?
Yeah,
We learned
So we can do it 92.
92. All right. All right. So now that we have these numbers, to simply see what they would get, we would just add them all up. So we come here, say equal sum of y-intercept plus what we calculated. All right. So if they were to make a 87 on exam 1, if you look up here, there's 87 in the equation box, and a 92 on a exam 4, they would get a total points 443.45. What does that mean in terms of the letter grade? To do that, we'll simply say 443, and we're going to divide that number by 500. Yeah, maximum. We got that from the data. And we see, if I want to make a percentage of this, that they would make an 89 in the class, or there's a 90% chance that you would be able to make that 89. Yeah, and that was our R squared. Yeah. Okay, that's a serious student, but what if you want to figure out, what if you're not just a good student?
So if you're a serious student, we can say they can make a 40.
So yeah, so if they're not serious, we'll come back to our formula up here. So play with this. So say they make 40 on exam 1, and then on exam 4, make 65. Improved a little, but still not that. Yeah, so if they made a 40 on exam 1 and a 65 on exam 4, they would get a total point. They would have a good chance of getting 265 total points, which percentage-wise is a 53, which means they failed. Yeah, so they're not, they were not a great student. The first student we did was a good student. He had a high B. Hopefully the teacher would give him a few extra points for an A because he tried. But that is pretty much data regression as a whole. We can use this again to predict grades, or companies can use it for other stuff, but we're going to cover that in part 2. So with that, y'all have anything else y'all want to add to the data regression project? All right, well, this is future CPAs, and we will see you in part 2.
Bye.
Yeah.